All right, I think let's get the show on the road. Okay, so guys, we had actually left each other. Okay, so this is a grade 10 live session, by the way. Grade 10, let me just grade 10. Okay, grade 10 maths paper 2. So we had sort of concluded analytical geometry, even though, of course, as I had said to you, that the questions that we went through are not every question that you can ever expect in a paper, but at least it gives us an idea. Okay, so let's move on to trigonometry. Let's give trig a chance. Let's give trig a chance. All right, let's give a chance. Trig a chance. So grade 10. Hopefully you are ready for this next concluding segment of revision. Grade 10. Okay. So if you look at what we have there, okay, grade 10, in the questions that you tend to get for trigonometry, there are firstly your substitution type questions. So there we have it. 3.1 says, we are still gathering our study material. You should have been ready, Lerato. You were the one that was sending me messages. You should have been ready long time ago. Still gathering your study material. You were the one person who was supposed to have your study materials gathered. Funny. Funny, Lerato. Ay. Study materials. Okay, this is grade 10 pure maths to those hopping in the live. Okay, let me just start off with some brief trig notes. For trig grade 10, we know the following. This one we should all know. Okay, because our friend here, Sokator, applies only where right angle triangles are concerned. So we have the basic trig ratios. Okay, we have the basic trig ratios, right? And we know that they are sine of theta. Now guys, theta is just a letter of the alphabet. Remember, in the Greek, there's theta, there's beta, there's alpha, there's phi, there's many others. But in English, we have letters A, B, C, D, E, F, G, H, I, J, K. All right, they all stand in the place of an angle. Okay, all of them stand in the place of an angle. And preferably, All right. We would want to have that angle being acute, but if not, then it's fine. So sine of angle theta here is OH, meaning it's opposite over hypotenuse. If we are on a Cartesian plane, then we look at the right angle triangle in terms of R, X, and Y. And depending on which quadrant we are, X, Y, and R, they change depending on which quadrant we are in. There is no ways that that right angle triangle will look any other way. So if it's here, there's the right angle triangle. If we here are positive, always R is positive wherever we are. Here Y is positive, here X is negative. Okay, then here Y is negative, here Y is negative. Okay, X here is positive. All right, so very important. Okay, because this is the y-axis, this is the x-axis. The x-axis this side is negative, the y-axis here is negative. Okay, so sine theta is opposite over hypotenuse. Remember guys, whatever angle we are referring to, if they ask us what is sine of beta, then beta is opposite this side, so this would be the opposite side, and that would still be the hypotenuse. So we always read a trig ratio from the angle that is being referred to. So if they want sine theta, I come here and I ask myself, where's the opposite side? There's the opposite side. Where's the hypotenuse? There is the hypotenuse. Okay, if they say sine of beta, then I come to this angle and I ask myself, where's the opposite side? What is opposite beta? It's this side. So here's my opposite side to this angle. And where's my hypotenuse? There it is. So that is why it's very important to understand which angle are they referring to. So since cos of theta is here, we know cos of theta is adjacent over hypotenuse. And then lastly, tan of theta is opposite over adjacent. So this mnemonic is very helpful. Okay, sine is opposite over hypotenuse. The sine ratio is opposite over hypotenuse. Sine of theta is opposite over hypotenuse. Sine of theta, opposite side, the side opposite theta. Hypotenuse is always opposite 90 degrees. Hypotenuse, guys, is the longest side of the triangle, and the hypotenuse is always, forever, always opposite 90 degrees, always. So sine theta is opposite over hypotenuse. Cos ka, a adjacent over hypotenuse. Remember guys, if you are looking at theta, adjacent means next to, the angle next to, the side next to the angle. That's what adjacent means, next to. So next to theta is this side, not the hypotenuse, guys, because remember, the hypotenuse is always opposite the 90-degree angle. So if you say sine theta, you mean this opposite side, because theta is opposite that side, and then this hypotenuse. That's the ratio. Cos theta, remember, the definition of cos is adjacent, the side next to the angle theta, adjacent over hypotenuse. Okay, then tan theta is opposite over adjacent, O over A, opposite over adjacent. The adjacent side is always next to the angle we are referring to. Okay, then there are the what we call the reciprocals. Okay, yeah. Now sine theta is equal to 1 over cosec theta, or you can say cosec theta expressed in terms of sine is equal to 1 over sine theta. Or if we are being specific about the angles and sides, that means cosec theta, because cosec is the reciprocal of sine, then cosec theta is not opposite of hypotenuse, but it is hypotenuse over opposite. Okay, so this is the relationship between sine and cosec. Sine and cosec are reciprocal trig ratios. They are inverse trig ratios. They are opposite trig ratios. Hence, you have sine theta being opposite of hypotenuse, whereas cosec is hypotenuse over opposite. Okay, now let's move on to cos. Cos theta has a reciprocal trig ratio of 1 over sec. Or we can say sec theta is 1 over cos. Okay. The reciprocal trig ratio of cos is sec 1 over sec. So that's why cos is adjacent over hypotenuse, whereas sec theta is hypotenuse over adjacent. It is the inverse or the reciprocal of cos. That's what sec is. Okay. Then lastly, 3. Tan theta is equal to 1 over cot theta. So hopefully, grade 10s, you understand that tan theta is equal to 1 over cot theta. Or differently stated, it means cot theta, the reciprocal, is equal to, expressed in tan, 1 over tan theta. Okay. So all grade 10s need to know this, the basic trig ratios, right? Sine, opposite over hypotenuse, so cos, adjacent over hypotenuse, ka, toa, tan, opposite over adjacent. Then they need to know the reciprocal trig ratios. That sine has a reciprocal trig ratio of cosec, which is 1 over cosec theta. Or, differently stated, cosec theta can be expressed in terms of sine. It is 1 over sine theta. Important to know these expressions, because sometimes in certain equations, you are required to convert cosec into 1 over sine in order to solve something. And you will see what I mean by this. Cos is 1 over sec, or sec theta can be expressed as 1 over cos theta, because these are reciprocals. Tan theta is 1 over cot, or in other words, cot theta can be expressed as 1 over tan. So we just forgot here to say that cot, therefore, theta can be written as, if tan theta is opposite over adjacent, then it means cot theta is adjacent over opposite. Very important, this thing here. Very, very important. Okay. Yeah. This all applies, these trig ratios, they apply in right-angled triangles and in no other triangles. The definitions apply to right-angled triangles and to no other triangles. Okay. Yeah. Now, coming back here. In this, what we call the Cartesian plane, we have what we call the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay. As I had said, in these respective quadrants, right angle triangle will be like this. In this quadrant, right angle triangle, right angle triangle, right angle triangle. So it's like a butterfly of some sort. And as I had indicated, the y values here at the top are positive, whereas the y values here at the bottom are negative. The x values here on the left are negative, the x values here on the right are positive. R on the Cartesian plane for whatever terminal arm is always positive, but your x and y will be changing depending on which quadrant we are in. So x here is positive whilst y is positive. X here is negative whilst y is positive. X here is negative whilst y is also negative. X is positive here whilst y is negative. So that's very important here, what we are able to utilize there. Okay, because when it comes to the Cartesian plane, we ought to understand what is the situation in each quadrant. Okay, yeah. Very, very important to understand the situation in each quadrant. So I hope that basic understanding we have there helps us a lot. Let us first come here then and look at some questions that are exam type, and then we can take it from there. I think whilst we are here as well, let us look at our trig graphs very quickly. There are three basic trig graphs. We have what we call the sine graph, the cos graph, and the tan graph. The sine function, the mother sine function, importantly, 0, 90, 180, 270, and beautiful 360. I mean, you could obviously extend it even to the negative angles, and I'm sure you'd see the shape. Very important, guys, that we understand that sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, and sine of 360 is 0. The basic shape of the sine mother graph is something that you should know off by heart. All right. Accompanying that is these special unique angles. Sine 0, which is 0, sine 90, which is 1, sine 180, which is 0, sine 270, which is negative 1, and sine 360, which is 0. A few facts. 1. Amplitude of the mother sine graph. What do we mean by amplitude? Amplitude, guys, is basically the distance from the position of rest to the maximum. So the position of rest is this x-axis, and to the maximum means from 0 to 1. So the amplitude of this particular sine graph would be equal to 1. Okay? Or we use a formula to calculate amplitude, and we say maximum minus minimum divided by 2. Amplitude is a distance, so it's supposed to be positive. Alright? So if you look at the maximum point where this graph, the mother sine graph, touches, it touches at the y value, which is 1. You look at the minimum value where this graph touches, it touches at negative 1. So that means 1 plus 1, because this negative times the negative gives me a positive, will give me 2 over 2, which is 1. So we say the amplitude of the mother sine graph is 1. Alright. That's one aspect, amplitude. Period. This is referred to as the full complete cycle. Complete cycle of the function. How many degrees does it take to complete one cycle of the function? So one full cycle of the sine graph takes 360 degrees. So guys, this is how a cycle of the sine graph looks like. From a position back to that position. All right, not necessarily to here, no, the whole way through. All right, so this would be a complete cycle. Takes how many degrees? 360. And that cycle repeats itself every 360 degrees. So we say the period of the mother sine graph is actually equal to 360 degrees. Okay, coefficient of theta is 1. So that stands to reason that indeed it is, the period is 360 degrees. So we have an amplitude of 1, a period of 360 degrees, all right, which sometimes the period, we can also use the word, because sometimes they will try and, sort of like confuse you. And instead of using period, they'll use frequency, which means the same thing, all right, just applied obviously in trig graphs. Probably here applied not in trig graphs but in waves. In physical science, when you do waves, then frequency is spoken of, and it has direct sort of like relationship with what period is. Okay, hopefully here we will not have people being gotten. Louise, I see what you said, the trig was the one that got me in school. Hopefully it doesn't get these kids here. All right, it should actually help them. They should get it, not be gotten. Okay, so amplitude, period. Then we discuss things like range. Okay, what is the range of a function? Range means the possible y values where the function exists. Possible y values where the function exists. So if you look at this function with the complete full cycle, where is this function existing for y? So you need to look at the bottom to the top. The function seems to be existing from -1 and it continues to exist all the way to 1. So it is existing from -y all the way to 1. So when we write the range, we can say y is an element of, and we can say square brackets -1 to 1. And we can write square brackets there as well to indicate that the function is existing at -1. It's there, it's present. But it exists even in between all the way to 1. And even there at 1, it is existing. So when we look at range, we are starting from the bottom. Okay, we are looking at the function from the bottom to the top. This is an important thing to note, that when you are talking about range, you are looking where does the function exist from the bottom to top. Okay, and the actual fact, when you write the range, you start from the bottom, the smallest value, to the top, the biggest value, and obviously indicate that so that we know that it exists everywhere. You could obviously write the range in this way if you wanted to, in inequality form. This is also 100% correct. Whether you write it in interval notation or inequality form, which is basically incorporating set builder if you want, then you can. Okay. Then the domain of the function. If the function is restricted from 0 to 360, you could say x is an element of 0 to 360, but typically this function will basically exist everywhere from left to right. What is the reason for what? What are you talking about, Louise? You're saying what is the reason for what? Okay, guess you're losing me there. What is the reason for that? Reason for what? You use the lowest number first, because as I explained, the range is the possible y values where the function exists from the bottom to the top. Why from the bottom? Because we start from the lowest number, and then we want to see from the lowest number to where does the function exist. We do not say from the top number to the bottom. We say from the bottom number to the top. The reason why we put square bracket for -1 is because the function touches -1, which means -1 is included. The reason we put square brackets even for +1 and not open brackets is because square brackets mean that the function touches +1, and therefore the function is included at +1. So that is why we say y is an element of square brackets -1 to 1 square brackets, not open, because open brackets indicates that the function is not included at that end point. And obviously we can't use open brackets. Okay? Include -1, touches -1, the function. Include +1 square brackets, touches 1 for the function. Okay, so that's amplitude, period, range. Okay, yeah. And then some other things they like looking at is where does the function increase and decrease. So if you look at this function, okay, if you look at this function, yeah, you see the thing is, Louis, you will write that order. But the interesting thing is that when you count numbers, you count from the smallest number to the biggest number. Yet, when you write your answer, you want to write your answer as if when you count, you are somebody that counts from the top down, which is not the situation. So please, learners will be penalized if they write top number to the bottom. We don't do that when we write the range. We write the range in the order from bottom to the top, from smallest to biggest, from left to right. Because from left to right, from the left we are counting smaller numbers all the way to the top. Interval notation must be written in ascending order, not descending, please. Okay, please don't put descending, otherwise your marks will descend with you. As you put in descending order, your marks will descend as well. Okay, FYP will call you here because you are descending. Y is equal to cos theta. Okay, sorry, I was saying they can also look at amplitude, all right, is basically the maximum minus the minimum divided by 2. Okay, that's what the amplitude is. You take your maximum value. If your maximum exists, you take it, you subtract your minimum value, then you divide it by 2 to get your amplitude. So what is the maximum number? It is y. By maximum we mean the top value for y. That is maximum. Okay, the highest point that your function reaches. So it is +1 minus the lowest point that your function touches, which in this case is -1. So this formula already has a minus sign. Okay, the maximum is +1, the minimum is -1. The formula already has minus. So you say negative times a negative is a positive. So we have 1 plus 1 in the numerator. That 1 plus 1 gives you 2. 2 divided by 2 gives you 1. So that is our amplitude. Amplitude is distance, guys. It is a distance, so it is supposed to be positive. It can never be a negative number, the amplitude. Okay. Now let's go to cos theta. The graph, you always take the maximum minus the minimum and you divide by 2 to get the amplitude. Okay, take your maximum value in the function minus your minimum value from the function, you divide by 2. You always divide by 2 to get the amplitude. Let's go to the cos graph now. Right. Domain wango is the possible, okay, I just mentioned it in juice. I said possible x values where your function exists. Okay, so this function, the sine graph, we can say that the domain, depending, you see here, for instance, it's starting from 0, it's ending at 360. So we can say x is an element, of 0 to 360. Okay. But typically, if the function is an infinite function, it goes on forever. We then say x is an element of real numbers. All right. Okay. So we must always check when they give us the function, have they given us a restrictive domain? Because if they give us a restrictive domain, meaning they say it starts and it ends somewhere, then we need to align our domain with where it starts and where it ends. Okay, from that place where it starts to that place where it ends, because domain is the possible x values where the function exists. And when we look at domain, we look at it from the left to the right, from smallest to biggest. But if the function is infinite, it's unrestricted, then we say x is an element of real numbers. What does this mean? It means that the function exists everywhere from left to right. Okay, it exists everywhere from left to right. Okay, so domain is possible x values and we read it from left to right, whereas range is possible y values. We read it from the bottom to the top. Okay, range y values, y-axis, domain x values, x-axis, left to right, whereas range y values from the bottom to the top. Okay, let's look at the function cos theta. Just a rough mother graph. If it starts at 0 all the way, let's say, to 360. So we have 0, 90, 180, 270, 1, negative 1. Cos graph, you can check with your quickly. Cos 0 is 1. Okay. Sine 0 is 0, but cos 0 is 1. Cos 90 is 0. Cos 180 is negative 1. Cos 270 is 0. Cos 360 is positive 1. So the mother graph goes like this. Okay. Then I'm sure you guys can sort of like conclude the amplitude. Okay, you can see maximum is 1 minus minimum, that's negative 1. So 1 plus 1 in the numerator divided by 2 is going to give us an amplitude of 1. So the amplitude of the mother cos graph is 1, just like the amplitude of the mother sine graph, which is 1. Okay, so the cos graph, guys, starts at positive 1. It starts for the y value of positive 1, whereas the sine graph starts at the value of 0. Okay, and this is the basic shape if the coefficient of sine theta is positive. There it is, guys. You see, it goes up, down, swerve, and that's it. That's the shape, guys, of the mother graph. Look at the cos graph, slightly different, because it starts at 1, goes down to 90, goes to 180, 270, 360. That is the mother course graph. Okay. No special effects yet. It's still the mother graph. You know most that children come from the mother. You know, generations come from the mother. So for now, we are still dealing with the mother, the parent graph. Okay. Yeah. The minute we start having changes, we add another number here as the coefficient. Something happens to the mother graph. We then add a Q value. Something happens to the mother graph. We're going to look at those things just shortly. So amplitude for the mother graph is 1. Period. So the period of the course graph completes a full cycle, which it repeats. The period of the mother graph, guys, completes a full cycle at 360 degrees. One full cycle is completed in 360 degrees. This is the important wording. It's completed in 360 degrees. So every 360, that cycle should repeat itself. It takes 360 degrees for us to see a full cycle of a mother course graph. So that was the same thing with the sine graph. If you remember, the period of the sine graph was also 360. So these are things that are the same between the sine and the cos graph. Their period is 360 degree tens. Are you with me? Okay. Yeah. Then let's move on. Range of the mother graph. Yeah, we're dealing with the mother here. Obviously, same thing. Y is an element, square brackets, -1 to 1. All right. Or you could write it in that inequality form. Okay. Domain. If it is a restricted graph from 0 to 360, then we would say x is an element of 0 to 360. But in the event that the function is unrestricted, it is infinite, then we know that x is an element of real numbers, would definitely satisfy the domain of a mother course graph. Yeah, where there's no restrictions, x is an element of real numbers, meaning the function will exist everywhere from left to right. Okay. Yeah. Then what other thing? Oh, for both functions, sometimes they like asking this question. They say, for which values of x does, let's say they say the course graph, where is the course graph increasing? Okay, for which values of x does the course graph increase? So let's look at the shape and the pattern of the function. Here the function is going down, so that means here it's decreasing. Okay, it decreases from 0 to 180, right? Then from 180 all the way to what? To 360. From 180 to 360, it's increasing. So we must be able, when we write our answer, to identify where the function is decreasing from where to where. We're looking from left to right. So from 0 to 180. You can write your answer in interval notation. So it's only decreasing from 0 to 180. But what's happening from 180 to 360? Look at the function. It is increasing again. Okay. So you should be able to, in interval notation, if they ask you for which values of x is the function increasing, you should say from 180 to 360 using an appropriate interval. Okay. Then I want to look at this last mother graph, time. Everybody's favorite. First things first, how does this function look like? 0, 45, 90, 135, 180. Okay. 225, 270, 350, 360. I just want to show you something by doing this actually. 1, -1. Gerardo, what about decreasing? I just explained decreasing. Are you even listening, Gerardo? Because you're saying what about decreasing? I explained decreasing. This function is decreasing here. Okay, it is decreasing here. But from where? From the left, here is starting at 0 to 90 to 180. So from 0 to 180, the function is decreasing. So if you were to write for which values of x as the function is decreasing, you would say where x is an element of, you would include 0, okay, to what? To 180. Now you have the choice, you can include or not include, okay, because there's an argument amongst, you know, your mathematicians about whether what's happening here. At this point, is the function decreasing specifically there, or is it stationary? And therefore, there's been an argument about including or not including. But examiners, they will mark you correctly whether you include or you don't include. All right. So from 0 to 180, guys, the function is decreasing. Whether you include or don't include the value of 0 doesn't matter, to be honest. Okay, you will not be marked incorrectly if you include it. You will not be marked incorrectly if you don't include it, because there is that argument, and that argument allows for both options to be accepted. From 0 to 180, you can include or not include, as long as you have the interval where there's an indication of 0 at the beginning to 180 for where the function is decreasing. Then where is the function increasing? Well, the function is increasing from 180 to what? To 360. You would write that interval for increasing. Come here. What's happening here? The function is increasing. From where? From 0 to 90. Then from 90 to 180, what's happening? It's decreasing. From 180 to 270, what's happening? It continues to decrease. So this function is decreasing all the way from 90 all the way to 270. Then from 270 to 260, what's happening? It increases. So we see, guys, we need to understand this. It increases from 0 to 90. It decreases all the way from 90 to 270. Then it increases all the way from 270 to 360. So when you are asked to write these intervals or the values of x for which the function is decreasing, you must be able to follow the function and then look at the x values that show decreasing and increasing and write those intervals accordingly. Okay? I trust you will be able to do that shortly. Let's go to the tan graph. Tan graph is very interesting. Tan 0 is 0. Tan 45, unlike in the other graphs, you know, our interval spacing, where 0 to 90 was the interval spacing, you know, we increased by 90 in the x-axis. We had that interval spacing, but here in the tan graph, the mother tan graph, our interval spacing, so that we can accommodate the inclusion of +1 for 45 degrees, we increase by 45. Then at 90, we have that beautiful thing that usually features even in hyperbola and exponential functions that we call what? What do we call this thing? What do we call? Let's see in the comment section if your maths is good. What do we call this thing? This one. We call it a thank you, Shasha. Asymptote, Loki. Thank you, Hoto. Thank you. Asymptote. Thank you. Yes. So we have a vertical asymptote at 90. So interesting enough, that's what happens with this function. It increases infinitely as it approaches 90. X is equal to 90, which is the vertical asymptote. It increases at a very infinite pace. You know, usually something I like saying to the learners is I say to them, type tan 89 in your calculator and see. Remember, tan 45 was 1, but it's very interesting. The minute you approach this 90, So you type in tan 89 in your calculator and you check what you get. Your answer is so big compared to 1. Tan 45 was 1, but it's so crazy how quickly this function increases as it approaches and gets closer to 90. So tan 89 is so far removed from the value of 1, which was tan 45. Okay, yeah. And you can actually write even closer values. Tan 89 point, maybe 3 nines after the 9. You'll see that this function, the closer and closer it gets, it's like the higher and higher this function on this side is. Okay, then tan 135 is -1, but interestingly tan 91 is very negative. Okay, tan 180 is 0, tan 225 is +1, then tan 270 we have another situation of a what? Of an asymptote. So that means this function goes like this, infinitely decreases, goes like that, infinitely increases, approaching this asymptote but never touching it. Okay, then same thing here. Tan 270, you'll find tan 271 immediately is a very, very small value. 315 is -1, 360 is 0. And then basically what's happening here, what you notice is that this cycle is going to be repeating itself every what? Now look at from here all the way to here is how many degrees? 270 minus 90. That speaks to the period. The period of what? Of the tan graph. Why? Because a full complete one cycle of the tan graph is basically taking us 180 degrees to be able to complete. Okay, 180. Unlike sine and cos, the period of the tan graph is 180, not 360. It's 180 degrees. Okay. Additionally, does the tan graph have an amplitude? The tan graph has no amplitude. Maybe you're going to ask yourself the question, why? Remember, what did we say amplitude is? The maximum minus the minimum. What is the maximum of the tan graph? Hey, my later, there is no maximum. Infinity is not even a number. Okay, so infinity is not even a number. There's no maximum. What is the minimum? There is no minimum value, because negative infinity, this function goes on forever. So seeing as that is the case, there can't be any amplitude. All right, there is no amplitude for the tan graph. Okay, then what about range? Possible y values where the function exists? Well, definitely. Y values where the function exists, y is an element of real numbers. Letabo, what do you mean? So if it comes to the test and they ask you what is the amplitude of a particular tan graph, you simply write no amplitude. You can't say 0. All right, the amplitude is not 0. It's not. And the amplitude is not undefined. The amplitude, there simply is no amplitude, guy. No amplitude. Okay, there is no amplitude. Right? Okay, there is no amplitude. Okay, then range, y is an element of real numbers. The function will exist everywhere from the bottom to the top. Okay, and then domain. All you need to do, guys, for domain is you just simply need to exclude the what? The asymptote. X cannot be 90. X cannot be 270 degrees. You know that X is an element of R, but only with these restrictions. Okay, you restrict all of the asymptotes. Okay. Yeah, and I believe you can actually say X cannot be 90 plus K 180 degrees, where k is an element of integers. Okay, that would be the general solution, that x cannot be that, but x is an element of real numbers. Okay, with the exclusion of all these values you would get from this general solution. Okay, I think we got there. All right, for an infinite function of time. Okay, I think I kind of like, yeah, let's leave this and let's go and actually, attend to some questions that have to do with trig. So let's come here. First question here, exam type. If theta is equal to 55, 13 degrees, alpha is equal to 72,3, beta is equal to 35 degrees, calculate the value of the following rounded off to 2 decimal places. Guys, this is checking your calculator skills. All right. This is doing your calculations. They're checking your calculator skills here. And if you are not very sharp, problematic, you come here, you substitute 55, 13. So you will need to just make sure that when you are doing things in our calculator, you are doing them accurately. So I would say, obviously, cos, you go and substitute 55, 13. Okay, we close that bracket, followed by what? Minus sine. Now sine, what's alpha? Alpha is 72,3. Okay, then plus tan squared b plus tan. Now I would say tan b 35 degrees, and I also know that this guy is going to be squared alone at the end, which is very key. So then my answer that I get is this one. Okay, I just want to show you here. So first it was cos theta, which is 55, 13. So I substituted in the place of theta, I substituted 55, 13. Minus sine alpha. Sine alpha is 72,3 minus sine in brackets 72,3 plus tan. Now this here, tan squared beta, right? Tan squared beta, guys, is the same thing as saying tan 35 the whole thing squared. Tan 35 the whole thing squared. So what I did is I said tan 35, put it in brackets, and then a special bracket for the entire thing, the whole thing squared. Okay, then I pressed equal. Equal. I got 0.10. Now they said round off to 2 decimal places. Now very important. Okay, so in my calculation of this, I am definitely going to first write down my substitution out of what I am writing down, so that the person who's marking me knows what I did. Cos of 55, 13 minus sine alpha 72,3. It makes a world of a difference. Okay, what answer did you get? Tan 35 squared, because that's what the tan squared means. That tan squared means the entire thing squared, the entire thing that you have. So all right, so it's good if you got the same answer as mine, that's fine. Then your answer is 0.11. Okay, remember when we round off to 2 decimal places, we count 1, 2. We look at the third number. What does 9 say to 0? because 9 is 5 and more, it means that this 0 becomes 1. So it goes up by 1. So our answer is 0.11. This is not an angle, so we don't write degrees. This is a numerical value. Please, guys, it's not an angle. So you leave it as 0.11. Okay. Hope we are clear. 1 mark for substitution, 1 mark for your answer from the calculator. I believe that's how they roll. Next, tan of what? Alpha plus beta minus theta minus sine cubed alpha over 2 sine beta plus theta. So let's write this down. 3.1.2 cos of the alpha 72.3 degrees plus the beta 35 degrees minus the theta 55.13 degrees minus the sine of cubed alpha is 72.3 degrees over 2 sine the beta plus theta. Beta is 35 degrees, theta is 55.13 degrees. So I am going to now grab the calculator because I've done my substitution. I'd say it looks good, right? Looks midi-midi. Now I'm just going to use that option of the fraction so that I can just punch in everything. So that's cos bracket 72.3 plus 35 plus minus 55.13, close the bracket, minus, then because I know that that is a cubed, I'm going to say sine 72.3, okay, the whole thing cubed, sine 72.3, close the bracket, open the cubed on the outside to the power 3 over, now in the division it's 2 sine what? 2 sine 35 plus 55.13, close the bracket. Just verify and check that all the values have been inserted correctly so that I don't get an answer that will basically deviate from what I'm anticipating, or at least that is far off. Okay, just to check again that I put everything. You see, look at this, made a mistake there. That is supposed to be what? 72.3, but I omitted the 2. Imagine now I typed in equal, and then I got my answer and I was sure. But you see how important it is to verify that in the calculator whatever was there is actually now present. You see, it's key. It's key when you say equal. Our answer is negative 0.13. Okay, hopefully you guys also got that. Negative 0.13. Okay, that was nicely done. Nice move, nicely done. Okay, nicely done. Now let's move on to the next set of questions. Determine the size of x rounded off to 2 decimal places. Now we get there. You got 0.04. I wonder. You see, me, I spotted my error. I don't know about you. Did you spot your error? Because me, I spotted my error and I know where the error was, but I corrected it. So I think you also made your own error. Yeah, but it's a matter of spotting it, because I've just double checked, my calculator. When I press equal, it's still that value. negative 0,13. So it's not me. It's not me. Okay, let's come here. Determine the size of x rounded off to 2 decimal places. Okay, now we have left the world of substituting into the calculator. That is the first type of question we can expect in trigonometry, but now we are here where we have to solve for x. So we have 1 minus 2 cos x plus 35 degrees is equal to 0,97. Okay, for how many marks? You're kidding me. These guys, they are not kind. So look at this, guys. 1 minus 2. So this 1, we can transpose it. We get left with negative 2 cos x plus 35 degrees. This 1 we can transpose. Be very careful, guys. You don't say 1 minus 2. You can't subtract this 1. Okay, you can't subtract this negative 2 from this 1 because this negative 2 is multiplied to this cos. So subtraction cannot happen between these two. Sometimes learners make that error and they think you can subtract 1 minus 2. No, you can't. We take the 1, we transpose it. Okay, that means 0,97 minus 1. You see? Yeah. Then after doing that, we can divide both sides by what? By 2. Okay? No, not just by 2, but by negative 2. Why are we dividing by negative 2? Because the coefficient of this trig ratio is negative. So, alright, divide by negative 2. What we do on the left, we do on the right. So that will leave us with cos x plus 35 degrees. This here stays with the angle. We cannot take 35 and put it over. We can't do that because this is part of the angle. We call this a compound angle. Okay? Yeah, I hope it makes sense, guys. So that is actually equal to 0,97 minus 1 divided by negative 2. Now I know some of you are like, I will say, why don't you simplify this thing? I have my reasons. Then we isolate the compound x plus 35. We take arc cos on the other side. Okay. Now I'm going to simplify that thing. 0,97 minus 1. Okay. Okay. Then I divide that. Yeah. My network, I don't know what happened there. That answer. I don't know what happened there. Sorry, guys. It paused there for a moment. My network went go-guy. I don't know why. I don't know at all. Okay. But hopefully you guys got the answer. Alright? Yeah. Okay, you get that 89,140 whatever it is. Then you say x is equal to, you transpose 89,140 minus 35. So that gives you x is equal to 54,14. Rounded off to 2 decimal places there, because it does say determine the size of x, round off to 2 decimal places. So we just did that. So you guys 100% spot on. Good job. Okay, very good, very good. Yeah, very good. You guys are good. Okay, right, let's move on to the next question. Look at this one. Okay, okay, this is them just trying to make life a bit complicated, but I'm sure you guys can see what you can see. Okay, yeah, so in the denominator, in the numerator, you have 6 tan x minus 25 plus 4. In the denominator, you have sine 30 minus cos 30. And then you have the plus 2, which is a separate term from this fraction. So I think our first objective is to take the 2 over so that we can get negative 10,93. I think we can all agree on that. Negative 10,93. Okay. Then whatever is here, we can cross multiply to the other side. Obviously, these are sine 30 and cos 30. We should use our what? What do we use there? Hopefully we know our special angle triangle. I think that's one thing I forgot or omitted to talk about. The 2, the 60, the 30, the 1, the root 3. That's the right angle triangle for the special angles 30 and 60. And then of course we have the other right angle triangle with 1, 1, root 2, 45, 45. So these special angle triangles, we use them whenever we have situations where sine 30 and cos 30 are in the mix, because 30 degrees is a special angle. Okay, so that means we can evaluate these angles. Okay, hence I was saying after transposing the 2, we can cross multiply sine 30 minus cos 30. We multiply both sides by sine 30 minus cos 30. That cancels it here, and then we find ourselves having sine 30 degrees minus cos 30 here on this side. Does that make sense? Then this 4 thereafter can be transposed as well. So that's 6 tan x minus 25 degrees. We then transpose the 4. It becomes negative 4. Then we divide by 6 as well. I hope you guys get the point. We divide by 6 as well. So if I divide both sides by 6, then very easily minus 10,93 into the sine 30. Okay, let's just use the sine angle. Sine 30 is opposite over hypotenuse. So that is like half minus cos 30. Cos 30 is adjacent over hypotenuse. So that's root 3 over 2 minus 4. Then you remember I said we divide everything by what? By 6. Yeah, so this whole entire thing is divided by 6. So what's beautiful here is that at the end, we can just take tan inverse of this entire thing. Right, and I think our calculator can help us out very handsomely with being able to figure out what the value is. Okay. Figure out very nicely what the value is with the x minus 25 waiting very patiently. So I'm going to pull out my calculator, as I'm sure you have pulled out yours. I'm going to say shift, then I have my tan inverse there that is very much open, and I'm going to use my fraction approach. I'm going to say negative 10,93, put the sweetanyana brackets there, have my 1 minus the root 3 over what? Over the 6 over the 2, sorry. Then open the bracket, have minus 4, and then down there I'm gonna put my 6, and I'm going to check what the answer is that I get. Ooh, doesn't look good. Negative 10,93. All right, let's just check. Okay, 1 minus root 3 over 2. Okay, SD. Okay, that's fine. Oh, you multiply, we multiply that by not comma. We multiply it first by negative 10,93. So we take this, we multiply it by negative 10,93, which will give us a positive answer. Then we subtract 4. Oh, so it must mean it's a very small number. That's why I'm like wondering what's happening here. Okay, that's SD. And we times that by negative 10,93. Okay. Now obviously if we subtract 4, we have 0,0006. So if we subtract 4, that is weird. Then we divide that by 6. Then what do? We take tan inverse of this. So shift, just check this, shift, tan, the answer. We get that. Then we subtract, sorry, not subtract, but we add 25 when we transpose it. Oh, there we have it. Okay, I think what scared me was the values that I got. If I round off to 2 decimal places, it's going to be 25,01. I was wondering what was happening here. Okay, so at the end of the day, it's just me. I got freaked out by the scientific notation that I saw. Okay. So negative 10,93, I need to just multiply by what is in this bracket, okay? I get that value, then I subtract by 4, then I divide by 6. You're going to get a scientific notation value. You take the arc of tan for that value, then you transpose the minus 25. You add 25 to that value. You should get 25,01 degrees. You should get this 25,006. But 2 decimal places means what do you do to the 0? You go up by 1. Okay, I hope that makes sense. I hope now it makes sense, guys. I'm sorry about the bit of the complication. I really complicated things, but they were simple. So please, equations, guys, make sure that we are able to maneuver in solving equations. All right, trig equations for grade 10. All right. Turn our attention. Okay, so we've done equations. We've got the right answer. Can you see your answer? There's my answer. 25,01. Negative 10,93. That's multiplied. Remember, BODMAS says you multiply stuff first, then you subtract 4. Then after that, you can divide by 6. And then, of course, you take the arc of tan for this entire thing first. And remember, this here is still intact. You take the arc of tan of this entire thing. Then after you are done, you can take the negative 25, transpose it, then you add 25 to whatever you got from this. You should get 25,01 degrees. That should then be your answer. Okay. That's my answer. What answer did you guys get? What if you use calculator on the special angles, not the numbers? Right, this is kind of like an unspoken expectation that when there's special angles, you should at least substitute using the special angle triangle. That is like an unspoken expectation, you know? Yeah, but still you'll get 0.5 Moss, and whatever value it is, it should still lead to the very same answer. Okay. Next question. Special angles. Okay, guys, special angles. Cos squared 30 minus sine 60 times tan 30. Determine without using the calculator the value of. Okay, so I'm just going to do 4.4.1 and 4.4.3. So let's start with 4.4.1. 4.4.1. Cos squared 30. Remember, we use our triangles. 1, 2, 1, root 3, 60, 30. 30, sorry. Yes. 2, 1, root 3. The root 3 is always opposite 60, the 30 is always opposite 1, and the 2 opposite 90. Okay. I remember someone telling me that if you want to remember this, imagine you have an equilateral triangle. All the sides are 2. Okay. You half it. That becomes 1 and 1. Since you half to the side, it means you also half the angle, which means that becomes 30 and 30. So that means if you take the one right angle triangle, that is going to be 2. That is going to be 60. That is going to be 30. That is obviously 1. And then if you use Pythagoras, you will get root 3. So that's how I have learned to remember the right angle triangle. That has 1, 30, and 60. Anyways, cos squared 30 open the bracket, you put the square on the outside. 30 is what? Cos 30. Okay, remember that's like saying it's cos 30, but you squared it. So what is cos 30? Cos 30 is adjacent over hypotenuse. So that means root 3 over 2, the whole thing, squared, minus sine 60. What is sine 60? Opposite over hypotenuse. This is 60, so it's opposite of hypotenuse. That's root 3 over 2 times tan 30. What's tan 30? This is 30. So tan is opposite over adjacent. So it's 1 over root 3. 1 over root 3. Then, when you are busy with this, don't forget BEDMAS. Brackets, exponents. There's your brackets, there's your exponents. So that means you need to actually attend to that. So that means root 3. Remember, for laws of exponents, if you apply the square to the root 3, that becomes 3. Apply the square to 2, that becomes 4. Minus root 3 times 1. Remember, the minus you don't subtract. In BEDMAS, brackets, exponents, division, multiplication comes first before subtraction. So I can't subtract this and that before multiplying these two. So multiplication has to be attended to first. Root 3 over 2 times 1 over root 3. Remember, this root 3 and this root 3, they cancel. You get left with what? 1 times 1, which is 1, and then 2 times 1, which is 2. So that means I have 3 over 4 minus 1 over 2. This here can simply be done very quickly. LCD is 4. So we 4 times 1, 2 times 2, times 2 at the top. That means we have 3 minus 2 over 4. That means the final answer is 1 over 4. As you guys have clearly said, I did not use a calculator at all. Okay, I did not use a calculator at all. From the substitution, I used the special angle triangles to the application of BEDMAS, where basically I did the bracket with the exponent, and then of course I did not subtract this with the negative root 3 over 2 because multiplication has to be done before subtraction can be done, and that's how I was able to get 1 over 4. Okay, very straightforward, applying all the mathematical knowledge that has been learned in earlier grades. Let me do number 3. Instead, I just want to do those two. Sec 60 plus cosec 30 plus cot 45. So this is another situation of determine without using a calculator the value of. So once again, what is sec 60? Go to the special angle triangle. Remember, sec is the reciprocal of cos. Okay, I remember that from my notes. Sec is the reciprocal. Sec is the reciprocal of cos. So if cos is adjacent over hypotenuse, sec is hypotenuse over adjacent. So I'm going to go to the 60-30 triangle, locate 60, and let's say hypotenuse over adjacent. So that's 2 over 1 plus cosec 30. Cosec is the reciprocal of sine. It's hypotenuse over opposite. Okay, hypotenuse over opposite, that's cosec. So let's go to cosec and go to the 30-60 triangle. Cosec is, this is the hypotenuse over opposite. This is the side opposite 30 degrees. So it's 2 over 1. So once again, plus cot 45. Cot, what is cot? Cot is adjacent over opposite. So I'm going to go to the 45 degree angle triangle. What is the 45? The 45 is 1 1 root 2 45 with a 90. So they want what? Cot 45. That means Okay, I'm going to come back to it. I'm going to look at it again. If I messed up, I'm more than happy to admit that I messed up because I'm not flawless. Cot 45. Thank you so much for that, Lerado. I'm going to check it out just now. Let me just finish this. Cot 45. What's cot? Cot is adjacent over opposite. So that means I'm going to go to cot 45 and I'm going to say adjacent. This is the adjacent side of 45. I'm going to say adjacent over opposite. So adjacent over opposite means 1. Okay, let's go back to sec 60. Okay, sec is the reciprocal of cos. It is hypotenuse over adjacent. So we want sec 60. Where's 60? Here is 60. Sec 60 is hypotenuse over adjacent. That's 2 over 1. Hypotenuse over adjacent. Okay. So the first one, sec 60, is 2 over 1. Okay. Cosec 30. Cosec 30 is a hypotenuse over opposite. Hypotenuse over opposite. So it's also 2 over 1. Okay. No problem. We make mistakes, don't we? I could have been the one that made that mistake. 2 over 1 is 2 plus 2 plus 1. What's 2 plus 2 plus 1? Alright, guys, it's 5. So straightforward this one. Okay. Sino cosa toa. That's fine. You mean you've learned trigonometry that way? Okay. Now, I want to go to some Pythagoras type problems, because we've done substitution with numbers, we've done special angles, we've done equations for trig. Now let's look at these type, where we have to sketch and take stuff in that way. Given 5 sine theta minus 4 is equal to 0 and 90 degrees and theta is between 90 and 270, or in other words, theta is greater than 90, less than 270. Using a sketch and without using a calculator, determine the value of the following. 5.1 sine theta over tan theta, 5.2 9 tan squared theta minus 5 cos theta. So let's just take this one step at a time. The first step that they usually say for these Pythagoras type question is that we need to make here the trig ratio the subject of the equation. So we need to take 5 sine theta and make sine theta the subject of the equation. That's how we always roll with questions like this. So let's write down 5 sine theta minus 4 is equal to 0. Let's write it down. Let's make sine the subject of the formula. We isolate 5 sine theta, take the negative 4 over, then it means sine theta is equal to 4. We divide both sides by 5. That means sine theta is equal to 4 over 5. This is step 1 in answering these questions. We isolate the trig ratio. We get the trig ratio as a numerical trig ratio. Okay, now what is this? This is y over r. In other words, opposite over hypotenuse. Why do I put y over r? In the Cartesian plane, this is the y value. This is the r value. Now also we know that sine theta is actually what? Positive. In other words, sine theta is greater than 0. Why do we say that? It's because the number 4 over 5 is a number that is greater than 0. So we can say sine is positive. That is the first piece of information we can gather from the trig ratio. Sine theta is equal to 4 over 5. 4 over 5 is a positive value. If, let's say, for instance, it had said sine theta is equal to negative 4 over 5, then we would have said sine is negative. Okay? So I hope we are good, guys, when we say sine theta is equal to 4 over 5, and the fact that this ratio is y over r, or opposite of hypotenuse, and because this value is positive, it means sine is positive. Then we have an interval. Step 2. We need to interpret the interval. Okay. When they say theta lies between 90 and 270, that means what exactly? Now we can actually go to our Cartesian plane roughly and locate the quadrant where our special triangle is going to lie. Okay. Right. Yeah. I don't understand. Your PC won't dance. Were you here when you guys, I feel like Nani, you guys to some degree, you are not as considerate as you would, you guys write down comments in the comment section. I go through stuff, you keep quiet, you allow me to go and go and go, then somewhere, then you come and you say, I don't understand that thing, I don't understand. So if you guys don't speak in time, make it very difficult for me. I'm not gonna lie to you, right? So you guys now are asking, all right, oh, you just arrived, sure, okay, even more. So these are reciprocal trig ratios. Your concern is, how do you convert? Remember, sine and cosec are what we call reciprocal trig ratios. So sine theta can be written as 1 over cosec, but cosec can be written as 1 over sine. So if you have cosec and you want to write it in terms of your basic trig ratio, because you know that sine is in the calculator, cos is in the calculator, and tan is in the calculator, but these are not there. You want to convert cosec to become, your reciprocal trig ratio sine. Then cosec theta is equal to 1 over sine theta. Okay. I don't even know that name is. Like you are dancing. Are you dancing or are you listening? Okay. Cosec theta is equal to 1 over sine theta. That's how you express cosec in terms of sine. Okay. You're listening, eh? Can I move on? Are you good with cosec? Right? Because I said sine and cosec are reciprocal trig ratios. Sine is opposite over hypotenuse, while cosec is hypotenuse over opposite. I get womb dance. That means if you still don't understand, then dear, I'm very sorry. Maybe you're going to need your actual teacher at school to explain to you, because honestly, I asked you, are you listening? And you said you are. What don't you understand? That you need to explain to me. What part don't you understand? Okay, because as I said to you, sine and cos are reciprocal trig ratios. Do you understand the word reciprocal? They are inverse trig ratios. Sine, by definition, unless you don't even know what sine is by definition, because if that is the case, then the problem is even there. All right, sine theta is opposite over hypotenuse. But cosec is the opposite of this. Cosec is hypotenuse over opposite. Okay, because this trig ratio is not in your calculator, but its reciprocal is sine. So if you want to express cosec in terms of sine, then you say cosec theta is equal to 1 over sine. Okay, you're not saying cosec is equal to sine. No, you say cosec is equal to 1 over sine, because this cosec theta, its reciprocal is sine, but expressed in terms of sine, it's 1 over sine, because it's the reciprocal. Yeah. I get when a baby girl, when you have no grounds to even speak, you understand nothing. You're not in that grade. You shouldn't be understanding anything, because if you came in now in the life, of course you shouldn't be understanding anything. Okay, Guys, unfortunately, like I said, I think you guys also need to, play your role. You guys have teachers at school. Please utilize them. Also, if you feel like maybe you're not understanding me very well, it could well be that you don't understand me. That's okay. There are other YouTubers and the TikTokers. There's a variety of teachers that you can go and subscribe to. Maybe Kevin Maths and Science could explain it even way better and you would be clear for days. So maybe also you could utilize. There's also Miss Angler. There is many teachers, that can teach you, and maybe they will appeal to your, to you specifically. Let me allow you that space, because so you see, now I've lost my trail of thought here, so I need to come back to this statement. Okay, so given, as I was saying, 5 sine theta minus 4 is equal to 0, and the fact that theta lies between 90 and 270, I said the first step is we need to isolate this trig ratio, which is sine theta. So we do that by, we write down 5 sine theta minus 4 is equal to 0, and then we transpose the minus 4. 5 sine theta is equal to 4. Then we divide both sides by 5. So that means sine theta, bye baby girl, sine theta is equal to 4 over 5. This is the trig ratio sine theta. It's equal to 4 over 5. Then I said to you that this numerator stands for y, the opposite side. This denominator stands for r, the hypotenuse side. So your y and your r are relevant in the Cartesian plane. That's why we feature them. Then this 4 over 5, is it a positive or a negative number? 4 over 5. Obviously, 4 over 5 is the positive number. That means sine is what? Is positive because of this positive number. So we can conclude and say sine is positive. Okay? Or sine theta is greater than 0 because of this 4 over 5. Step 2, we take the second part, which is theta lies between 90 and 270. Okay? Alright? If it didn't give us that the triangle would be between 90 and 270, usually they will write and say maybe cos theta is greater than 0. There'll be something else. There's another restrictive measure that these people will write to accompany this. Your restrictive measure can either be written as an interval like this, or it can be written as a trig ratio to indicate its positivity or negativity. So if they say cos theta, for instance, is greater than 0, then it means cos is positive. Then you would have to utilize that information. Okay, but if there is no other restrictive measure at all, because usually this equation is accompanied by a restrictive measure. If there's no restrictive measure at all, then of course you are going to roll with the fact that sine is positive. And you know where sine is positive, it can be positive only in the first or the second quadrant. So ideally, if the angle is acute, you would want to actually represent your diagram in the first quadrant. But always take note of the other restrictive measure. In most cases, when they give these questions, they put a restrictive measure. Okay? All right. So I hope so far, those who are on the live, who are with me, who did not join midway or halfway or something like that, we are still together with this. Okay? Now, I am going to come here and ask myself now, because I've gathered this information, I'm going to ask, where is sine positive? Where is sine positive? Sine is positive in the first and the second quadrant. That's based on the fact that sine theta is 4 over 5 and is positive. Sine is positive in the first and the second quadrant. Then my restrictive measure, theta lies between 90 and 270. Where is 90 and 270? 90 to 270. 90 degrees is here. So that means this quadrant and that quadrant. Where do I have a intersection of quadrants, of ticks. In which quadrant? It is in the second. So when I draw my sketch now, I draw my terminal arm and then I complete my 90-degree angle triangle. Okay? Then this means my diagram is in the second quadrant. I come back to my ratio, 4/5. R is 5. So I write R there. It is always positive, of course. Y is 4. Y is 4. Y is there. I hope we are together. Okay. Dance. First quartile. What is that now? First quartile and fourth quartile. A donative girl. I'm lost. A donative girl. What grade are you in? Are you grade 10? And please specify to me, are you lost in step 1? I explained step 1. Okay. Where are you lost in step 1? Let's go step by step. Where are you lost in step 1? Where are you lost in step 1, a donative girl? You say you are lost, but you need to tell me where you are lost. Where are you lost, a donative girl? Which place in step 1 are you lost? If not in step 1, where in step 2? Won't dance. It's not that I'm fast. I think I'm sorry. Nope. I don't agree with you. Guys, most of you are going to feel out of your depth because maybe the truth of the matter is, okay, you see now, I feel like some of you are going to pin your problems on me. You're pinning your problems. Okay, that's problematic for me. Okay, and I can kind of sense it when it's like that. The drawing. Okay, let me go back a little bit. It's not that I'm too fast. Remember, guys, I'm not teaching you here. I'm revising. Revising is supposed to, I say something, it's supposed to bring back some of the things that you learned. I understand that it may have been a while that you did trigonometry, but remember, at some particular term you did trigonometry, you wrote tests. You either passed or failed those tests, or you understood the content or you didn't. All right, so what I'm doing here is revising, not teaching you. So if I'm ending up teaching you, it must mean that maybe even when you were taught, you did not understand. Okay, now that's not my baby, my problem. You see, because some of you now, you are saying, I'm too fast. No, I'm not. Me, I am going and I'm explaining what I have here. And I'm asking you to comment, but you are not commenting when I ask. All right, or you are waiting for me to finish, and then when I'm far ahead, you want to pull me back to where you were lost. So you should also have a sense of urgency in asking a question if there's something that you're not clear about. That's important, okay, for time's sake as well. So I said here 5 sine theta minus 4. This is the equation, okay? But we need to isolate the trig ratio. Our goal with this is to have a trig ratio isolated. So this sine theta needs to be alone on the left. So that means minus 4 needs to go to the right. A 5, which is multiplied to sine theta, needs to also be somehow taken to the other side. So we do it according to procedure. We take negative 4 over to the other side. It becomes positive 4. We have 5 sine theta isolated. We then divide both sides. Because 5 is multiplied to sine, you must divide by this 5. What you do on the left, you do on the right. So the 5 is gone here. You have 4 over 5 here. What is this? It's a ratio. What is at the top? It is y, which is the what? The opposite side. What is in the denominator? It is 5. It is r, the hypotenuse. This 4 over 5, is it a positive or a negative number? This 4 over 5 is a positive number. So that means sine is what? Is positive. Please get that in your heads, guys. Sine is positive. So that means this sine is positive idea is going to help us in being able to locate in which quadrant our right angle triangle should be drawn. If we don't highlight this thing that sine theta is positive from the ratio, then we cannot utilize information here to be able to locate where our diagram will be drawn and in which quadrant. Not quartile, quadrant. Okay. In a Cartesian plane, you have a first quadrant, second quadrant, third quadrant, fourth quadrant. There are 4 quadrants. Okay. So we're saying sine is what? Is positive. So then my question is, where is sine positive on the Cartesian plane? Guys, according to the ASTC rule, in quadrant 1, all trig ratios are positive. In quadrant 2, sine is the only one that is positive with its reciprocal. Tan is the only one that's positive with its reciprocal quad. Cos here is the only one that's positive with its reciprocal. Meaning all other trig ratios, cos and tan in this quadrant are negative. Sine and cos are negative in this quadrant. Tan and sine are negative in this quadrant. But in this quadrant, all trig ratios are positive. So when I ask you, where is sine positive? You use ASTC. All students take cameras. You use that to do what? To locate the quadrant. So I'm asking now, where is sine positive? It is positive in the first quadrant because all trig ratios are positive, and it is positive in the second quadrant because sine alone is positive in that quadrant. Then we come to the restrictive interval. Theta lies between 90 and 270. What you must note is that on the Cartesian plane, for your angles, this is 0, this is 90, this is 180, this is 270, this is 360. That is something I'm thinking you should know. So when I say theta is in the middle of who? Of 90 and 270. Which quadrants am I talking about? 90 all the way to 270 is speaking about the second and the third quadrant. So where do I take? 1, 2. I'm done with locating using ticks. Now I go and ask, where do I have the most ticks? In which quadrant do I have the most ticks? The quadrant that has the most ticks is the second quadrant. That is where my diagram will be drawn. Okay. Hi. If you are still lost, then I'm sorry. I'm a hopeless teacher. And you know what? You need to get out of my life now whilst you still can, so that you can actually save yourself from this disaster. Please, please, please. Right? I am a hopeless teacher. You need to get out of here ASAP. Okay. Now, here, since we have a right angle triangle, remember when I was talking about 4 over 5, I said 4 is the opposite side, it is y. 5 is the hypotenuse side, it is r. Okay. Y is 4. Y y-axis is 4. 5 are the hypotenuse. This bottom part, we need to find the value of x. And our x value, because our triangle is on this side of the Cartesian plane, we are expecting a certain sign for x, for the x value that we get. The question is, will x be positive because it's on this side, or will it be negative? That is the million-dollar question. So how do we find the value of x? We use Pythagoras. Thank you so much, Coco Pan. It will be negative, that x value. So we're going to say r squared is equal to x squared plus y squared. What is r squared? R squared means the square of the hypotenuse side. The hypotenuse side is always opposite 90. This is the r value. So we're going to say 5 squared is equal to x squared. X is what we want. Y squared is 4. Let's not forget the reason. Pythagoras. Then 5 squared is 25. X squared is x squared. 4 squared is 16. You take the 16 over, 25 minus 16 is equal to x squared. The 25 minus 16 gives you 9. That is x squared. You take the square root on both sides. When you do that, you don't say anything but plus, minus. That is to indicate that you understand there are two values of x. One positive, the other one negative. That means the answer is positive or negative 3. But because we are in this quadrant, our value of interest is negative 3. So we are going to write here negative 3. That is the true value of x. We don't take positive because in this quadrant, x is not positive, but x is what? It's negative. The diagram is close to completion. Okay, right? And basically, when we have it, and we have all the sides, then we can move on and we can proceed to answer the questions, because we now have, by using a sketch, we have our sketch without using a calculator. We haven't used the calculator. We are now going to determine the value of the following by using our what? Our sketch. So all that we did here, isolating the trig ratio, finding that it's either positive or negative, understanding what that means, ticking the quadrants, understanding the interval, ticking the quadrants, locating the diagram, the right angle triangle where it falls, using Pythagoras, getting the value of the side that is missing. All that was to help us to do what? To get the sketch so that we can use it to basically simplify and calculate what is given to us there. So now we need to calculate 5.1. We need to get what the value of sine theta over tan theta will be. So this is easy because this is the same thing as saying sine theta divided by tan theta. I hope it makes sense to you. The line means division. Sine theta divided by tan theta, we can write it like that. Then we can go to our diagram and read sine theta. Remember, sine is opposite over hypotenuse, which means 4 over 5 divided by tan theta. Tan theta is opposite over adjacent. That's 4 over negative 3. Then all we do is we say 4 over 5. We change this divide sign to multiply. What happens to this fraction? When you change divide to multiply, what happens to this fraction? It gets inverted. It becomes negative 4 over 3. This 4 and this 4 cancel each other because they divide by each other. And then 1 times negative 3, that becomes negative 3. 5 times 1, that becomes 5. So our answer is negative 3 over 5. That is the value of sine theta. Remember, sine theta. Go read in the sketch what sine is. Go read in the sketch what sine is. Sine theta. Go to the sketch. Sine theta. Y over R. Opposite over hypotenuse. 4 over 5. Go read in the sketch what tan theta is. Tan theta is opposite over adjacent. Opposite over adjacent. So it's 4 over -3. Divide changes to multiply. The fraction inverts. Reciprocates. Inverts. Reciprocates. Inverts. Then we multiply. We get the answer. -3 over 5. -3 over 5. Okay. Get out of this life whilst you still can. This guy is creating a disaster for you. Get out whilst you still can. You are singing seriously. Yes, I am. What do you think? I'm singing. It's good. It's good. It's good. I'm singing. Cordelia. 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 It's got love. Cordelia. It's got love. Cordelia, like everything of yours, has just got hearts. Your profile picture has hearts. It's got 4 of them. It's Cordelia next to the name has hearts. It's just mbombozaring with love. What's happening? -3 over 5. That is the answer, guys. Okay. 5.2. 9 tan squared theta minus 5 cos theta. Let's look at this one. How do we simplify that? Well, same thing. 9 tan theta everything squared minus 5 cos theta. The square only affects the trig ratio, not the coefficient. The square only affects the trig ratio, not the coefficient. Please, guys, be very careful about that. Okay? Don't square the number. You only square the trig ratio. The coefficient is untouched. Now we can go and read from the diagram. What's tan from the diagram? Opposite over adjacent. So that means we have 9, but then we have -4 over 3 squared minus 5 in brackets. What's cos? Cos is adjacent over hypotenuse. -3 over 5. Do you see this, guys? The ratios substitute or replace the trig ratio. The numerical ratio replaces tan completely. The numerical ratio of -3 over 5 replaces cos completely. And remember, the relationship of 5 and this cos is one of multiply. That's why I put replace this thing and I put this in brackets. Please, guys, don't make a mistake of doing it otherwise. Then you apply bad mass. Brackets, exponent. 9 will come later. We have 16 over 9. This 9 is in the numerator. This one is in the denominator. Minus 5 into -3 over 5. Now, after brackets and exponents, there's division, there's multiplication. I can't subtract these before multiplying this and multiplying that. Let's multiply this and that. The 9 and the 9, they cancel. We have 1, 1. We are left with 16 this side over 1. The -5 times the -3 over 5 gives us a positive. But these two, they cancel each other. We're left with 1 and 1. So that's plus 3. The answer is 19. I hope you got 19 as well. Did you get 19? Please take note, guys, of what I just said. When you are having a tan squared theta, you must put the square outside the bracket, but the 9 is unaffected because the coefficient is never affected. It's only the trig ratio. Okay? Then please, when you choose, you go and select your ratio. We're saying, what is tan? Tan is opposite over adjacent. You write -4 over 3. The -4 over 3 replaces tan completely. Okay, please, guys, the -3 over 5 replaces, like substitution. It's like a Orlando Pirates game. When you have someone who is coming to substitute another player in the field, that player does not stay in the field. So cos cannot stay, but another player is coming to play. Negative 3 over 5 is coming to play in the field. Cos theta needs to get out all of him. Okay. Then you apply, please guys, the rules of bad maths. Don't apply funky stuff. Mathematical rules still apply. Okay, I think you guys also now are good with trig type. Okay, yeah, then of course we need to be well versed in, determine D in terms of Y and alpha, like, using our trig ratio and all of those things. Very important, these things. Very, very important. Like, we cannot butcher such. Okay. Okay. Me is so tired right now, it's not even funny. Yeah, I think all these people that have been asking these. Okay, let's look at this. On the given Cartesian plane on the diagram sheet, draw the graph of the function f of x is equal to tan x minus 1 for the interval negative 180 to 270. You see, they want us to sketch this graph, but in the interval negative 180 to 270. So they are basically wanting just a portion of the graph, not the entire. Well, they want us to draw this graph from here to there only. Okay, tan x minus 1. Okay, now imagine, what do you know about this graph? What does the minus 1 part mean? This minus part. This minus 1 part. It means the mother graph tan got shifted down by 1 unit. Remember, minus 1. Okay, that's the Q parameter. It means that if we say negative 1, that means the function, the mother graph shifted down by 1 to form this function. Okay, so we need to sketch that function for this interval. Then it says clearly show the asymptotes and the x-intercepts of the graph. Then lastly, the diagram below shows the graphs of f of x is equal to a sine x plus 2. Okay, so we are just going to sketch that graph. That's one question here. Just a question that says draw the graph of the function of this for the interval negative 180 to 270. Can you imagine, just for that interval? Okay. It's a pity that I don't think I have that diagram sheet that they basically allude that we should sketch on, because I believe there would be provided the much more called. Let's see, let me check. Maybe I do. Maybe I thought I didn't, but I do. Oh, I do actually. Is this it? Question 5. Oh, there we have it. Okay, there's the diagram sheet. It's provided. I love it when I find things that I thought I didn't have, but I have them. Okay. Okay, let's come here. Remember here they said draw the graph of the function tan x minus 1 for the interval negative 180 to 270. Oh, it's from the negative to 270. Okay, negative 180 to 270. Clearly show the asymptotes and x-intercepts of the graph. Okay, so here are the beautiful values. All right, and what's nice is I can use my calculator for this to sketch the graph. To be honest, I can. Okay, all you do is you say mode and then you say tabled. There you have it, f of x. Then you can just say tan. All right, and then you say alpha x. Okay, then you close that bracket and you just say minus 1. then you say equal. We don't need g of x. Where are we going to start? Well, it's very clear that they want us to start at negative 180. Okay, and then equal. Where do we want to end? At 270. Obvious. Okay, step. Now, what steps are we going to be taking? 45-degree steps. So let us just say 45. And there it is. There it is. There it is. Negative 180, which is here, is going to go hand in hand with what? Negative 1. Okay, negative 180 is going to go. So when x is negative 180, y is negative 1. That's where these two are. Negative 135 is going to go with 0. Negative 90 is going to go with error. Is this the case? Okay, are we good here? Is this true? Did I type? Why do I doubt now what I type? Okay, table. So I did say tan of shift x there, and then I said minus 1 equal to, okay, then I said start negative 180, sorry, 180, step 45 degrees. I said end. This guy. Okay, all right. So I want to sketch. What do I want to sketch, guys? Okay, these people who are joining in and they say start over are confusing me. Let's say this is grade 10, guys. This is not grade 12, you know? Yeah, let's say. So on the Cartesian plane, on the diagram sheet, draw the graph of the function f of x is equal to tan x minus 1 for the interval negative 180 to 270. So what we want to do is we are going to actually use our calculator to sketch the graph. Mode. We press mode. You see what we did? We pressed mode. Then we go to 3 because table says 3. Then we should see this functional notation f of x is equal to, then we can type in tan, then alpha in red, close, tan of x minus 1. So this should be typed, you know, as we see it here. Okay, and then we can say equal g of x. We don't want a second function. Start, we are going to start at negative 180. We are going to end at 270. Okay, and then we are going to have a step of 45. I just need to confirm, guys. Okay, so negative 180 goes with negative 1. All right, as per the sketch, when x is negative 180, f of x, which means y, is negative 1. When x is negative 135, f of x is 0. When x is negative 90, we have a maths error. What does that mean? It means at negative 90, we have a asymptote. Okay, which is, we always write that in, guys. And please, it's always good to label the asymptote. X is equal to negative 90. Then we go up. Negative 45 is negative 2. Sorry, negative 2, not positive 2. What am I doing? Okay, negative 2. Sorry, my bad. Negative, then 0 is negative 1. 45 is 0. 90 is error. 135 is negative 2. So 135 is negative 2. 180 is negative 1. Grade 10, guys, grade 10. 225 is 0. And then last but not least, 270 is L. Okay, there we have it. Easy does it. Okay. Okay. Yeah, so this is somewhat how your sketch would appear. Okay, really has shifted down, because usually for the mother graph 45 was there at 1, but all of a sudden it's down, you know, to 0. So yeah, I think that's definitely the function, right? Then what we do is we note the pivotal points. Of course they will be seeable, negative 45 and 40 and 2, you know. Yeah, negative 180 and 1, negative 1. No, these are pivotal points. 180 and negative 1, 135 and negative 2. See, these are important. So you have these points, you can then sketch the graph and then you label it, right? Label it, and the label there is f of x is equal to tan of x minus 1. Okay, sorts us out. We are good for days. We are good to go. Okay, for sketching, guys, you don't need to be at loss. You have a calculator, it can help you out a lot. Okay, the diagram below shows the graph of f of x is equal to a sine x plus 2. We don't have the value of a, we don't have the value of 2. Then it says given, and g of x is equal to negative cos x plus 2. Okay, so that means from the mother sine graph, you know mother is cos x, but if you have a negative a, it means the function reflected along what? Along the x-axis. Okay, it reflected, right? And then obviously plus 2 means the mother graph, it shifted up by 2 units. So we reflected across the x-axis and we shifted up by 2 units. But it's for this interval, negative 90 to 270. Point A is 126,87 degrees and 13 over 5. It is a point where f of x is equal to g of x. So 128 there. Show with clear calculations that a is equal to 2 and 2 is equal to 1. Where is a and 2? F. Where is f? Here is f. This function. So first things first, the y-intercept is 0 and 1. Okay, the y-intercept is 0 and 1. So how can we use the y-intercept 0 and 1 to get something? Okay. So let us be, if we have f of x is equal to a sine x plus q. If we have points 0 and 1, which is the y-intercept, I think the truth is we can say y is equal to a sine x plus 2, then y is equal to 1, a sine 0 plus 2. What you will notice is that the sine 0 is 0. 0 times a will give us 0. So that means our q value is equal to 1. Okay, I'm not taking a break because I need to actually go and sleep at 12. So I'm not going to take a break at all. At 12 o'clock, I'm just going to leave you guys wherever I stop. Because I can't really pull it any further, to be honest, because I have to work. I'm working tomorrow morning, and I have to be in the right state of mind. So angle Q is equal to 1. We've been able to show that quite convincingly. Okay. Now, what about A? What about A? Well, we can use that other point of intersection, which is 126,87 and 13/5. Hopefully by that we can find the value of A. So let's go and say we're going to substitute the point 126,87 and 13/5. So that means y is 13/5. A we don't know. Sine of 126,87 is there, plus 1. Take the 1 over. 13/5 minus 1 is equal to A into sine 126,87. So here, this 13/5 minus 1 will give us what? 8/5. You are going too fast. You see, the thing is, at this point, all right, unless when you can say that you still have a problem even here. Remember, 0 and 1 is a point that lies on the function. So if it's a point that lies on the function, it means I can substitute it into the function and then see what variable I can attain. So x is 0 there. Y is 1 there. So sine 0 is equal to 0 times A. That gives us 0. So 0 plus 2 is equal to 1, which means the Q value is 1. So that's how I was able to get Q is equal to 1. Now, having gotten the value of Q, this is the function. Remember, Q I have y is equal to A sine x. I have Q, which is 1 now. All I now do is substitute 126,87 and 13/5. Okay, yeah, because I know those points for sure, so I can substitute that. If you have any other points that are there that you know, you can use them as well. Okay, the question is, which points will you substitute? Okay. Is there any other points you could substitute that you know you can substitute? Yeah, so if you do, you can go ahead and substitute so that I know these ones for sure. So I substituted 126,87 and 13/5, which means y is 13/5, x is 126,87. Take the 1 over, becomes 8/5. You can use your calculator. 13/5 minus 1 is actually 8/5. Then you say sine of 126,87 and you check what you get. Sine 126,87. There it is. Okay. So that means A 0.79999899281. A is equal to that. Now I'm going to divide both sides by this. Okay, so that means 8/5 needs to be divided by that so that we can find what the value of A is.